We begin with problem 1, where we have a set of data representing 6 scores on a 10-point test. It is always wise when you get a set of data to put it in ascending order from least to greatest. We're going to go ahead and give the mean, median, and mode. The mean, of course, the symbol for that is X bar. If you were to take these 6 data points, add them up, and then divide by 6, because that's how many of them there are, you would get a 7.2. I would ask that you please pause and make sure that you can confirm that using your calculator. There's a lot of calculator skills involved with this subject. Next, we have the median, which, by the way, the symbol for median is X with a little squiggle on top. And X, I guess X squiggle, I don't know, is going to be, in this case, looking at this, we have an even set of data points. And so usually for the median, if we have an odd number of data points, it would be the exact middle number. Because we have an even amount, it's between these two. I would suggest not guessing or inferring. You can use mathematics to actually find this out. We would take the two middle numbers, find their sum, and then divide it by 2. In this case, and it ends up being 6.7. Make sure that whatever number you get for the median fits snugly in between this data set. And in this case, it definitely does. The mode for this problem is going to be none. There is no mode. Please take note of this note I have on the side here. Do not say the mode is 0, because 0 can be a data point sometimes, right? One of these friends could have actually gotten a 0 on the test. That would have been a data point. So don't say the mode is 0, because that means most of the students got a 0 on the test. Remember, one of the most important things to do when you do statistics problems is consider that this is real data, real sets, and they have a value to them. It's not just numbers, it's experience and it's life. In order to calculate the interquartile range, we will need Q1, Q2, and Q3. We already did find Q2, that was also the median. We have a value of 6.7 for that. The 6.7 fits nicely right here between all of this data. It cuts the data exactly in half. Now, if you consider, for example, this side right here on the left, right, the lower half of the data set, we do need a median. The median of the lower part of the data set will be Q1. So if we look at this part right here, we do have an odd amount of data set numbers. And so our middle number will be the first quartile value in this case. If we look at the upper half, this will give us our Q3. Again, we have an odd amount of numbers here, which is pretty convenient for us. And so we have 7.8 will be our third quartile. We can go ahead and set up a box and whisker plot. It begins with the lowest point right here, or we can start with the median, if you will. The median we said was 6.7, so here's quartile 2, the median. Quartile 1 is at the beginning of the box. This is the quartile 1. Quartile 3 is the end of the box. And then on the other ends, we have the minimum right here. Here's the min, and then the max. So this visual representation is called a box and whisker plot, or a box plot. And what it does for us, it visually represents the min, the max, the extent of this whole data set. We're able to pick up the median off of this quickly, the first quartile, the third quartile, the interquartile range. And we also recognize that this accounts for 50% of the data in this data set. Okay, so we've gone ahead and done a box and whisker plot. Part C. What if we go ahead and recalculate the mean, median, mode, but this time we remove the outlier. So the outlier in this case is going to be 1.2, right? There's always that one friend, unfortunately, who's not going to do too hot on the test, right? Sometimes they have a little bit too much fun, and then they pay for it. So we're going to remove the 1.2 from the data set. So our new data set, surprisingly enough, and this is pretty rare, it ends up being 7.2 still. Usually when we do remove an outlier, it will affect the mean. You'll see that in a future problem that we're going to do. The median, however, does become affected. The median actually becomes higher. Whereas before it was 6.7 in part A, the median is higher now because we removed that outlier, which was very low, and it was dragging some of the data down. The mode still remains the same. There is no mode. For your summary, explain in detail How to get the Q1, Q2, and Q3 for A data set with an odd amount of entries, and B, a data set with an even amount of entries. I would even suggest make up some examples. So maybe make up an example with, let's say, 9 numbers in it, and then make one up with 10 numbers in it, and then see what happens. And go easy on yourself. Use single-digit numbers, right, in a calculator. So go ahead and take some time for that summary. Okay, let's go ahead and begin applying some of these ideas. This is to give you a kind of a glimpse at what to expect with some of these problems. We're going to practice a lot more of this in class, and you're going to see a lot of different problems. In statistics, you could open any textbook and it wouldn't be do the same problem 20 times. Statistics is very unique in that you'll open up a chapter and you'll never do the same problem twice. Okay, so just be aware of that. Here we are given a minimum, a maximum, the median, and the first and third quartiles. Let's calculate the range. The range is going to be the max value minus the minimum value, which in this case would be 100 minus 20, which ends up being 80. So our range for this data set is going, and actually we weren't even given the data set. We just know that a set of data has these properties to it. So whatever the data set is, we do know that it ranges, right? It has a range of 80. Let's talk about the interquartile range. The interquartile range would be Q3 minus Q1. So this would be 80 minus 40, and this ends up being 40. So we have a data set with a range of 80 and an interquartile range of 40. Here's a data set. You'll notice there are 6 values in it. One of them is a variable. What value of x would result in there being 3 modes? Right now, the way it stands, this is bimodal. You'll see that there's a 2 here and a 2 here, and also a 1 and a 1. So as this data stands right now, it has 2 modes, and the modes are 1 and 2. If I wanted there to be 3 modes, x would have to be equal to 3, because we already have another 3 in the data set. If the median is 2, what are the possible values of x? So let's consider for a second, what if I did line these up, right? Because it's a median, so we're going to do the traditional thing of lining these up. However, we don't know if x is smaller or larger, right? I'm going to go with the assumption right now that x might be bigger, okay? So if I do this, consider for a moment that, the median set is 2, right? So right now, how it stands, if I look at this data and if I'm looking at x is bigger than that, it ends up being on this side of my organization. The way it stands, the median would be 2, right? Because 2 plus 2 is 4 divided by 2 is 2. So right now the median would be 2. Now so we know that x could be, right, it could be 4, it could be 5, it could be 6, it could be anything up to, positive infinity, right? Could it be 3? Well, if it were 3, it still wouldn't affect the median. Could it be 2? If it were 2, it would fit in this position right here, but my median would still be 2. So note that if, in this case, if x is greater than or equal to 2, then my median would be 2 no matter what. Okay? So that's the answer. Now, as far as a formula is concerned or a calculation is concerned, you have to just think about it, unfortunately. Okay? And that's statistics. It's a lot of thinking. Okay? What if x were less than 2? Well, let's say we're 1, for example. Do you notice that the median would no longer be 2? The median would be between these two numbers, right? 1.5. So my median begins changing. So if x is less than 2, then we know that then the median would end up also being less than 2 as well. It would no longer be 2. So in order for my median to remain 2, I have to allow x to be greater than or equal to 2 in this data set. Well, the mean is the sample mean, as is appropriately known in statistics. Yeah, we have multiple different means in statistics, but what we're doing right now is the average or the sample mean. It's all the numbers together in the data set divided by how many there are. And in this case, we know the mean is 11. So if you do some algebra, we end up getting 9 plus x equals 66 for this problem. And if we solve for x, we get 57. Now, remember, we're looking at this is not just math anymore where we just solve problems and get answers and get lucky. These numbers have to make sense. So consider for a moment, if you will, that if I'm looking at my data set and they're low numbers, but the mean is very high, something must have happened, right? Something high must have happened. So this outlier of 57, that's what affected the average. Here's a table of temperatures for 3 cities over a 4-day period. I'm going to go ahead and I'm going to extend this table out. If you go ahead and calculate these, and I leave that up to the listener to go ahead and confirm that with their calculators, I get a mean of 54 for Boston, a mean temperature of 47 for Chicago, and a mean temperature of 62.5 for San Francisco. There is no mode for Boston or for San Francisco, but we do see a mode here in Chicago of 47. The range of temperatures becomes pretty fascinating and important. Range in temperatures lets us know in real life harsh climates, weather conditions, right? For example, Lancaster, you know that sometimes it's going to be 98 degrees in the day and it'll end up being like 44 degrees at night. That's a huge range of data. Okay. Consider then for a moment, looking at these numbers, that Boston had the greatest temperature change over a 4-period day, right? It changed by 13 degrees. That's pretty substantial. It's noticeable. Chicago had the most days with the repeating temperature. That's because of its mode, right? It had a mode. And San Francisco ends up having less temperature fluctuation, so it's pretty predictable. You usually see that with your coastal cities, right? Your beach cities. You're going to go ahead and have that kind of a consistent temperature. So just a few things to note when you look at data. Okay, some things to consider to look into. Summary: explain problem 3B in your own words and use words.